My dear students of Rajakuttara Model College English Medium section, hope you all are well. Today I shall discuss a very important point of chapter 3, that is the chapter periodic properties and chemical bonding. The topic is the covalent character of ionic compounds. You all know that there are two types of compounds, ionic compounds and covalent compounds. But ionic compounds also possess some covalent character. Why an ionic compound will possess covalent character? We shall learn it details today. So let us start. The covalent character of ionic compounds. The cause of covalent character of ionic compound is polarization. Now let us be clear what is polarization. The deformation of the electron cloud of the anion by the cation and vice versa is called polarization. You all know that cation has an electron cloud, anion has also an electron cloud. Normally the electron cloud should be spherical since the atoms are spherical. But because of the positive charge on the cation, the electron cloud of the anion becomes deformed. Similarly, the electron cloud of cation also deformed by the anion, but the magnitude of the deformation of electron cloud of the cation by the anion is very small or negligible. But the deformation of electron cloud of the anion by the cation is very magnificent. Because of this deformation of electron cloud of the anion by the cation is called polarization. Look at this figure. This is the electron cloud of the cation. It is spherical, but the electron cloud of the anion has become deformed. It has been deformed because of the positive charge of the cation. Due to the deformation of this electron cloud, some electron density has come in between the two nucleus of the ions, that is between the nucleus of cation and anion. Since there are some electron cloud in between these two nucleus, this area is shared by both the cation and anion. This gives rise to the covalent character in an ionic compound. Now mind it, if the polarization occurs more, covalent character in ionic compound arises more. But we have to know clearly when more polarization occurs, when less polarization occurs. This factor is described by a law which is called Phagons Rule. So the factors upon which amount of polarization depends is governed by the law which is known as Phagons Rule. There are some points regarding these rules. We shall discuss these points one by one. Number 1 point, if the size of the cation is smaller, more polarization occurs. That is, polarization occurs more if the size of the cation is smaller. Let us see the example. We have the compounds potassium chloride, sodium chloride and lithium chloride. Anions are same. In all the cases, anions are chloride. The cations are different. The charge of the cations are also same. They are unipositive, but the size of the cations are different. Among these three cations, potassium ion is the biggest, then sodium ion, and lithium ion is the smallest. Because of the smallest size of the cation, the electron cloud of the anion has been deformed in more extent. That is, the deformation of the electron cloud of the chloride ion has taken more in case of lithium chloride. So if the size of the cation is smaller, more polarization occurs, that is more covalent character arises in the compound. So among these three compounds, potassium chloride, sodium chloride and lithium chloride possesses the most amount of covalent character, and potassium chloride possesses the least amount of covalent character. Sodium chloride lies in between. So the number one point, I think you all are clear that if the size of the cation is smaller, then more polarization occurs, so more covalent character arises in the ionic compound. Let us go to the next point. The next point is the charge of the cation. If you find that the anions are same and the size of the cations are also almost same, then the factor which is to be considered is the size of charge of the cation. If the charge of the cation is higher, more polarization occurs. That is, we have sodium chloride, magnesium chloride and aluminum chloride. Aluminum, magnesium and sodium are the elements are third period, so their ionic sizes are almost same, but the charge of magnesium ion is more than that of sodium ion, and charge of aluminum ion is more than that of magnesium ion. That is, aluminum ion has the highest positive charge and it deforms the electron cloud, the cloud of the chloride ion, that is the anion, in more extent. That is, more polarization occurs in case of aluminum chloride, so it possesses most amount of covalent character. In case of sodium ion, since there is only one positive charge, it deforms chloride ion in a small extent. For this reason, less amount of polarization occurs, so it possesses less covalent character. So among these three compounds, aluminum chloride is containing more amount of covalent character, and sodium chloride is containing the least amount of covalent character. Magnesium chloride lies between sodium chloride and aluminum chloride. We have another point. Let us proceed. The next point is size of the anion. If you find that the cations are same but the anions are different, then the amount of polarization will depend on the size of the anion. If the size of the anion is bigger, more polarization occurs. In this case, we have three anions: fluoride ion and bromide ion. You know, bromide ion is bigger in size and fluoride ion is the smallest in size, because fluorine is the element of the second period, chlorine is the element of the third period, and bromine is the element of the fourth period. So bromine is biggest in size, so bromide ion is also biggest in size among these three anions. Since if the size of the anion is bigger, more polarization occurs. You see in the figure, more polarization occurs, so more covalent character arises. And fluoride ion is very small, deformed. Fluoride ion is deformed in a very small extent. For this reason, a small amount of covalent character arises in case of aluminum fluoride, and aluminum bromide possesses highest amount of covalent character among these three compounds. Our next point is the charge of the anion. If you find that the cations are same and the anions are same in size, then we have to consider the charge of the anion. Fluorine and oxygen are the elements of the same period, so they have the same size almost, but fluoride ion has one negative charge, it is uninegative, but oxide ion has two negative charge. Since the charge of the oxide ion is more polarization occurs, so potassium oxide will contain more covalent character in comparison to potassium fluoride, because polarization occurs more if the charge of the anion is higher. Here the charge of oxide ion is higher than that of fluoride ion. For this reason, potassium oxide possesses more covalent character, since more polarization occurs in this case because of the higher charge of the anion. We have the last point now. It is a special case. If the last electron in d orbital, if the cation contains electron in the d orbital and the last electron enters into d orbital, its polarization power increases. I have given an example. Sodium ion, it does not contain electron in d orbital, but copper one, that is Q plus ion, contains d orbital and it contains electrons in d orbital and the last electron enters into d orbital. For this region, the polarization power of potassium ion, Q plus ion, is higher than that of sodium ion. Though the charge of the sodium ion is +1 and the charge of the Q plus ion is also +1 and the size of the sodium ion is smaller than the Q plus ion, sodium ion should have the more capacity of polarization, but because of the presence of the electron in d orbital, copper 1 ion, that is Q plus ion, causes more polarization. For this reason, Q plus chloride is more covalent than sodium chloride. These are the points to determine the covalent character of ionic compounds. We have to memorize all the points together to determine the magnitude of covalent character in ionic compounds. Now we shall discuss some problems. I have given some task for you. Arrange the following sets of compounds in the increasing order of their covalent character. I have given 5 sets. You will memorize the Phagons rule and arrange these compounds in the increasing order of their covalent character. I have also given the solution, but you try yourself first, then you will justify your result with this solution. I have given another question. Silver fluoride is soluble in water, but silver iodide is insoluble in water. Why? In this case, the explanation is also given here. Here the cations are same, but the anions are different. Fluoride ion and iodide ion, between fluoride ion and iodide ion is bigger in size. For this reason, more polarization occurs in case of silver iodide. As a result, silver iodide gets covalent character in a magnificent amount, in a considerable amount. For this reason, it gets covalent character and it becomes insoluble in water, because we know ionic compounds are soluble in water and covalent compounds are insoluble in water. But in silver fluoride, since the size of fluoride ion is very small, for this reason a small amount of polarization occurs. For this reason, a small amount of covalent character arises here, that is, it possesses mostly the ionic character. For this reason, it dissolves in water. Between silver fluoride and silver iodide, silver fluoride is soluble in water, but silver iodide is insoluble in water. This is the last point of today's discussion. Thank you very much for being with me. Stay home, stay safe.